The planets formed in two ways. One way is that the heavier elements from the terrestrial planets, the rocky ones, and the gaseous ones have been formed by the lighter elements. So the rocky ones are heavier, they are closer to the Sun, and the others are far away from the Sun. Among the terrestrial planets, we have one planet with a large moon, that's the Earth. So the question is, why did only the Earth have a large moon? And so we can imagine four possible theories which explain the origin and the evolution of a moon in the Earth-Moon system. The first one is that the Earth captured another body, the Moon, and forced it into an orbit around Earth. The problem here is we have samples from the Moon, and we know that the material of the Moon is very close to the material of the Earth's mantle. So it's unlikely that a body formed elsewhere in the solar system had the same composition as the Earth's mantle. The other theory is fission. So very fast rotating Earth can throw material out and this material can build a moon. However, we don't know that the Earth was rotating so fast at the beginning. The second thing is we know that the Moon is a little bit younger than the Earth, so if it happened simultaneously, the Moon should be as old as the Earth. The third theory is very close to this. It tells that both bodies co-erected at the same time, and built out of the same material. There we have the problem that the distribution of the material is not completely the same. We know that most of the iron is in the Earth and the Moon is depleted in iron, but has the concentration, the composition of the Earth's mantle. So co-accretion will not explain the depletion on iron. The fourth one is collision. So a large body collided with the Earth, destroyed the Earth's mantle, put material of the Earth's mantle and of the Earth's crust in the orbit of Earth, and there we built the Moon. So this theory most likely solves all the problems. We have a similar composition from the Earth's moon and the Earth's mantle. We can explain the depletion in iron. We can put all the smaller problems we don't understand into the colliding body. And we know that this happened after the Earth formed, so the Moon is younger. So in order to prove this, we really want to have samples not only from the surface of the Moon, but also from the mantle of the Moon. So the easiest way to get a sample of the mantle is to drill a hole. But the crust of the Moon is about 40 kilometers at least. Though another possibility is to look at very large impacts, collisional impacts on the Moon. And we know there are numbers of them on the Moon, and we know this because we have mapped the Moon starting from the Lunar Orbiter and Apollo missions. And in the meantime, we have a real good understanding of the geology of the Moon due to the missions we have running, like Lunar Reconnaissance Orbiter, and we pretty clearly know that there is a large impact basin on the lunar far side. It's called South Pole Aitken Basin. It's large enough to destroy the lunar crust and to hit the mantle. So scientists are eager to get samples out of this impact basin. Each rock contains radioactive elements which will decay. If you melt a rock, you set the clock to 0 and you get the formation age of the melt. And having this, we really know when this basin formed. So we get more information about the age of the Moon, and we also get material of the mantle because it's very deep. And these two informations are really needed in order to nail down the theory of the origin of the Moon.